This is the Math 03 Module 1 review, problem number 13. I have a little bit longer problem here involving decimals, but it doesn't change what I do. I follow the same rules as I did on the shorter problems. That means my first step on the left-hand side is going to be to distribute this multiplication. 0.15 times x is just 0.15x, plus 0.15 times 2 is 0.3. You can put 0.30. Either way, it's the same thing. Plus 0.3 equals 0.35x minus 0.4. I just rewrote the rest of the problem. Now on the left-hand side, I have like terms to collect. I have a 0.3 plus 0.3. So I have 0.15x plus 0.6 equals 0.35x minus 0.4. Now I'm going to move that variable term from the left to the right. Excuse me, I said that wrong. From the right to the left. So I'm going to subtract 0.35x to both sides. Okay. 0.15x minus 0.35x gives me negative 0.2x plus 0.6 equals negative 0.4. Of course, what I did here was I took the little one and subtracted it from the big one, working in my head. That meant I took 0.15 from 0.35, and I took the sign of the bigger one when I did that subtraction, which was the negative one. You, of course, can be putting that in your calculator for that accuracy. Now I'm going to move away from the x, so I'm going to subtract 0.6 from both sides, everything from both sides, and that gives me negative 0.2x equals negative 1. That's what I get when I add negative 0.4 to negative 0.6. And now I'm going to divide by negative 0.2. The left-hand side, it cancels. I'm going to move over here. That gives me x equals, and negative 1 divided by 0.2 is like 2 into 10. If I moved my decimal point one place on both of those, so that gives me x equals 5. And that's my final answer on that. And remember, to check your work, all you would do is take that 5 back to the original equation and plug it in and make sure you get the same thing on both sides of the equal sign. Okay, for number 15, I have 3 times the quantity a plus 8 equals 6 times the quantity a plus 4 minus 3a. So the first thing I'm going to do is the distributive property. 3 times a is 3a, plus 3 times 8 is 24, is equal to 6 times a is 6a, plus 6 times 4 is 24, and then write down your minus 3a. So now on the right-hand side, obviously I have like terms that need to be collected. 6a minus 3a is 3a plus 24. On the left-hand side, I still have 3a plus 24. Now if you recognize right here that both sides are the same, you know that this problem is an identity, but we'll pretend we didn't recognize that, and that means we would move the 3a over. So I'm subtracting it from both sides, and it canceled on both sides, which left me 24 equals 24. That means the type of problem this is an identity. The answer is all real numbers, because an identity means that no matter what value of the variable, in this case a, that you choose, when you plug it in, the left-hand side and the right-hand side will be in agreement. So the type of problem it is an identity. The solution to it is all real numbers, meaning any value of a would work to solve this problem. The instructions for problem 17 say solve each formula for the specified variable. Here I have a equals 2 pi r h, and I want to solve for h. That means I get h alone on one side of the equal sign and everything else on the other side. This is a pretty simple one because I'm simply multiplying h by 2 pi and r, and remember we always do the opposite operation, and that means I need to divide by 2 pi and r. They cancel on the right hand side, and I have h equals a divided by 2 pi r. I like my variable on the left, of course, so I have h equals a divided by 2 pi r. Remember, I did not change anything by turning it around. I simply put what I was solving for on the left-hand side in preparation for doing inequalities. On problem 19, I'm solving the formula C equals 1 over 4 times S times the quantity T minus D, and I'm solving this time for T, which means T is what I want to get alone. Well, the first thing I want to do here is get rid of that fraction, so I'm going to multiply both sides by 4, which of course cancels on this side, and now I have 4C equals S times the quantity T minus D. Okay, now I'm going to divide both sides by S because rather than distribute that in, I'm simply going to divide that out at this step. So I have divided by S, cancels over here. Now I have 4C over S is equal to T minus D. Remember, I'm still solving for T, so my last step is simply to add D to both sides. And I have 4C over S plus D equals T, or I'm going to turn that around, put my variable on the left, T equals 4C divided by S plus D. If you wanted that to all be in one term, you could have 4C plus D over SD. Find a common denominator. But this way is perfectly acceptable as a way to leave your answer. Okay, the instructions for these three say translate the verbal statements into algebraic expressions. Triple the profit P, number 21, means we're starting with P and we have to triple it. Triple it means multiply it 3 times, so it would simply be 3P. Okay, number 23, 7 less than the markup M, means I'm starting with M, the markup amount, and now I have 7 less than that, which means I have to subtract 7 from it. Remember, anytime you see less than, you change the order of the statement. If you see just less, you don't change the order. Less than, you change the order. So this is going to be M minus 7. That's 7 less than what I started with, which was the markup M. Okay, number 25 says 12 more than the expected growth G. That means I start with G and I'm going to end up with 12 more than that. To get more than that, I have to add to it. So it's G plus 12. Number 27, we're still translating the verbal statement into an algebraic expression. It says the product of the cost C and the amount X. So they're telling us to name cost C, and they're telling us to name amount X. And if I want the product of those two, product indicates that I multiply, of course. So the product of those two is simply CX.